The next force we're going to talk about is kinetic friction. Now, kinetic friction is the frictional force that you experience between two surfaces that are moving with respect to each other. If one object is sliding across another, or another object is being slid underneath an object, something like that. That's the force of kinetic friction that you're experiencing as those two objects are sliding. Now, the force of kinetic friction is basically the exact same principles as static friction. We still have these two objects that are in contact with each other. They have these ridges, this roughness underneath it. The difference between kinetic and static is that those two surfaces are in motion to each other. So no longer are all these crevices and peaks and stuff like that embedding themselves and interlocking with each other. It's more like you have a peak here and they're just slamming into each other, just going over each other. Okay? The way I like to describe kinetic friction and what's going on is there was once a story, there was a book I read about Aboriginal people, and they were talking about the roads out in the outback. Well, so there was a car, you take your Range Rover and you go out and this author went out and visited a whole bunch of Aboriginal people and was talking about the roads. Well, what you encounter when you deal with unpaved roads is you get washboard roads, which is basically this. It's a rough surface. You get these bumps in the road. Well, kinetic friction is if the best way to overcome that roughness, you still feel it, you still encounter it, is to go fast, because you're no longer sinking all the way to the bottom. You're no longer getting that maximum locking in you're not locked into place as well as you were before. So if this object's moving, then you're no longer getting, here's your crevice, here's your peak, you're no longer getting it to sink all the way to the bottom. It's trying to sink, but you're still moving. So you're getting that kind of motion. So it's considerably less than the static friction force. As a matter of fact, that's one thing you can always count on when you're talking about physics, is that the kinetic friction is actually always less than the static friction, the maximum static friction force. I should be careful there. It's not always less than the static friction force, but the maximum value for the static friction force. The equation for it is identical almost for static friction. The force kinetic is equal to the coefficient of friction for kinetic friction times normal. Now, that coefficient is not identical to the static coefficient. As a matter of fact, this kinetic coefficient is always a smaller value than the static coefficient, because the apparent roughness is less, because you're not sinking all the way down into those cracks. You're only going halfway until you're moving on. You move on to the next point. So this value, this coefficient of kinetic friction, is always less than the static friction force. So if your static friction force is some value like 0.5, you can expect your kinetic friction coefficient to be something along the lines of 0.2. Just, it's a smaller value. The normal is still, once again, referring to this. If I push down with a great deal of force, I'm responding with this much. So this is a measurement of how much force you're applying down on those two surfaces of contact. The force of kinetic friction, well, there's actually two things you got to keep in mind. First of all, the force of kinetic friction is perpendicular to the surfaces of contact. So there's that perpendicular motion, or perpendicularness, that we experienced with static friction. But the other thing you got to keep in mind is that this force of friction is always opposite the direction of motion of these two surfaces. So if this object is moving in this direction with the velocity, then you can expect the force of friction to be in the opposite direction. Okay? So if you're moving this way, you can expect the force of friction to be in the opposite direction. Okay, that's what we know about kinetic friction. That's the equation for kinetic friction. That's kind of the understanding of why it behaves the way it does. Now, going back to this graph of force applied versus the force of friction. Oops, look, I did a really bad thing. Don't forget your units. So we know this section here to be the static friction force. It climbs, it climbs, it climbs. Look, the maximum value is higher than my kinetic friction value. So static friction can be values greater than the kinetic friction value. So here's a force that's responding to the force that's being applied. Newton for Newton, 5 newtons here, 5 newtons here, up until it gets to here. But the interesting thing is once you've overcome the force of static friction, when dealing with kinetic friction, which once again you can only experience if the object is moving, if those two surfaces are moving with respect to each other, that the force of kinetic friction then stays a constant value. It doesn't grow if I apply more force. It doesn't reduce if I apply less force. It's always simply the force of kinetic friction. It's always just this idea, not like static friction where we had this less than or equal to stuff. Okay? So that's kinetic friction. There's one more frictional force, but we're not going to talk about it, and that's rolling friction. If you're interested, you should do some of your own research on it. It's actually very similar to everything we've seen here. Okay, but once again, this is kinetic friction. We're going to move on, talk about gravitational, and then we've got a couple more forces like tension to talk about, and then we'll move on. Okay.